Hi friends, I hope you're all doing great. Preparing really well for the upcoming CAT. Keep happy, stay motivated and don't give up till the end. In this part we are talking about graphs important for CAT and we'll also see a few applications in some of the CAT questions. We'll only see the graphs that are relevant, for example linear, quadratic, modulus and circle, out of which quadratic and modulus are the most frequent and the ones that are being used the most in CAT exams. So let's begin with the topic and let's understand it with linear. See, linear, as the name suggests, represents a linear function. One thing that you must revise for understanding this clearly is the coordinate, the video that we've done on coordinate geometry, where we've talked about some of these functions. If I have, let's say, a line which is y is equal to x, then how do you draw it? We have to know that how do you represent a linear function? Y is equal to mx plus c, right? Where m is the slope, we have done it in the basics of this, and c is the intercept on the y-axis, right? So something like this. Here slope is tan of this angle and intercept on y-axis is c. For y is equal to x, the slope m is equal to 1, which means tan theta is equal to 1, so theta is equal to 45. So y is equal to x, the angle with positive x-axis is 45 degrees. So this is y is equal to x. That is how as basic as it can get, and plotting linear graphs is very easy. Let me tell you one more, let me give you one more example. Let's say I have 3x plus 2y is equal to 6. So then I can write it as 2y is equal to minus 3x plus 6. I can write it as minus 3x by 2 plus 3. So very clearly we know that this graph, how do you draw this line? So this is positive x, positive y. We know that y-intercept is going to be 3. So let's plot this 0, 3. And how do I know x intercept? That's also very simple. If you put y is equal to 0, right? If you put y is equal to 0, then you will realize that the value of x here is equal to 2. So 2, 0. Now it's very simple. All you have to do is just join it and plot the graph. So how do you represent a linear graph? Very simple. To get the y coordinate, put x is equal to 0, and for getting the x coordinate, put y is equal to 0, and you have got 2 points. Just join the points, you get the line, right? So linear graph is very simple. Let's move forward and talk about quadratic, which is again a very important aspect of algebra as well as functions. So how do you draw? A typical quadratic can be given as y is equal to x square, which is nothing but a graph like this. So a graph like a parabola, right? So y is equal to x square will be something like this, and you can check it out. Put x is equal to 0, you will get y is equal to 0. Put x is equal to 1, you will get y is equal to 1. Put x is equal to 2, you get y is equal to 4, and it is symmetric about the y-axis. Why? Because you will put x is equal to minus 1 also, you will get plus 1. You will put x is equal to minus 2, you will get plus 4, right? So these points are symmetric. These points are symmetric. So very easy to understand this parabolic representation of y is equal to x square. Now let's see some variations. So y is equal to x square is very clear in my mind. Now if I have to draw, let's say y is equal to something like a 2x square, right? Then how can I draw it? Let's see. So y is equal to 2x square. What does it do to your graph? Your value of y will grow faster at x is equal to 1. Now the value is equal to 2, not equal to 1. Earlier it was equal to 1. Now it is equal to 2, right? So at x is equal to 1, the value is here. At x is equal to 2, the value becomes equal to 8. Right? At x is equal to 2, the value becomes equal to 8. So the graph effectively becomes steeper. When you multiply it with any number like 2 or 3 or any other number, then the graph becomes steeper, right? And what happens when you, let's say, divide it by any number? Let's take any other example. Let's say you take y is equal to x square by 2. What happens? Very clearly, now at x is equal to 2, the value of y will be equal to 2. So now the graph becomes flatter. It retains its nature, but the graph becomes flatter when you divide and steeper when you multiply. I hope the nature of graph is also clear to you. Let's talk about a few other aspects. Let's say I have y is equal to x square graph. I am erasing everything else. So I have y is equal to x square graph, right? And I want to plot a few other graphs. For example, let's say I want to plot y is equal to x plus a whole square. Now what will happen is that if you will have to, for x plus a whole square, you will have to put x is equal to minus a to make it equal to 0, to make y equal to 0. So therefore, now in this case what will happen? The graph will shift a unit to the left, right? At x is equal to minus a, the value of y is 0. So the graph shifts a units to the left. And similarly, if you have x minus a whole square, then it shifts a unit to the right, right? So a units to the right it shifts for x plus a whole square. Another case can be y is equal to, let's say, x square plus a. That is very simple. If you have y is equal to x square plus a, all you have to do is just shift it upstairs by a units. So then it becomes something like this. And if it is, let's say, y is equal to x square minus a, then shift it downstairs by a units, right? So that is how you draw a graph. Now let's take a full-fledged quadratic equation and quadratic expression and draw its graph so that we are absolutely clear. Let us say that I want to draw y is equal to x square plus 6x plus 10. How can I draw this graph? See, I can write this as x plus 3 whole square plus 1, right? So I know that y is equal to x square is a parabola, right? So something like this. But what will happen is it is plus 3. If it is plus 3, I'll have to put x is equal to minus 3 to make it 0. So it will shift 3 units to the left hand side, something like this. And then you have a plus 1 also, shift it 1 unit upstairs, make it something like this. So finally, what's the graph like? So the graph of x square plus 6x plus 10 can be drawn something like this. Always remember that a graph, this way of representation can be used to represent any quadratic of the form ax square plus bx plus c. You can try it out by taking a few other examples. So a very beautiful way of representing the graph of quadratic. Also remember one more thing, that in case of quadratic, when the coefficient of x square is positive, like in this case, you will always have a finite minima and infinite maxima. And the graph is also telling you that. If the coefficient of x square is negative, then the graph will be inverse. In that case, you will have a finite maxima and infinite minima. So this depends upon the coefficient of x square. I hope this is clear to you. Now let's have a look at a question which came in CAT to put things into perspective and to understand how graph can be used to solve questions. Let's see. So this question came in CAT 2018. This is something that we are going to solve now. So let's see how do you go about it. Let's take our favorite color to begin with. Now we have a coordinate axis. I have a line y is equal to 5x. Obviously y is equal to 5x is going to be a straight line like this, right? It's a linear graph. Next you have 52 minus 2x square. How do you draw 52 minus 2x square? Let's see. How do you draw a 2x square first? So y is equal to 2x square. So you draw 2x square something like this, right? And when you have to draw minus 2x square, all you have to do is reverse it, something like this. So this becomes minus 2x square. Now you have to add 52. So you just add 52, lift it upstairs by 52 units, right? So then it becomes something like this, right? So I have two graphs. This is y is equal to 5x and this graph is y is equal to 52 minus 2x square. I have to get maxima of both. Let's see, it's a beautiful graph that we are going to get. I have to get maxima of both. So see, from this point onwards, maxima is the straight line. From this point to this point, maxima is the quadratic bit. So you draw the quadratic here. Just repeat it. And again from this point onwards, maxima is the straight line. So fx is maxima of both. How do you obtain it? Quite simply, very simply, just remove everything and all you will have is the graph of fx. See, this is the graph of fx. I have drawn it here. I hope this is clear to you. Now, what is the minimum possible value of fx? X is any positive real number, so I don't need to care about the negative side of x. This is crossed. All I need to care about is positive, and I need to find out the minimum possible value. I am obviously getting it here. And how do I get? This is basically the intersection of quadratic and linear. So just equate it. Whenever you have to find out intersection of two graphs, just equate them. So 52 minus 2x square is equal to 5x. Right? So one way to do it is obviously, you can solve this quadratic equation. So 2x square plus 5x minus 52. So equal to 0. So 2x square plus 13x minus 8x minus 52 equal to 0. So you take x common, 2x plus 13, 4 common, 2x plus 13 equal to 0. So x is equal to 4 and x is equal to minus 13 by 2. The negative one is not allowed, only the positive one is allowed. So you take x is equal to 4 and you put it into any of it. So if you put x is equal to 4 here, the value of y becomes 5 into 4, which is equal to 20. So so this point is nothing but 4 comma 20, and the maximum value or the minimum possible value of fx will be equal to 20. So 20 is the answer. I hope this is clear to you. A very beautiful problem which came in CAT 2018. I hope this is absolutely clear. Many people know that they have to equate the two, but very few people know why do they equate the two. But I hope all of you know it now. Let's move forward and see modulus. Modulus is something that we've seen in the last part also. So let's quickly summarize it. If we have y is equal to mod x, it is given as x when x is greater than equal to 0 minus x when x is less than 0. So how do you represent a graph like this? Something like this. Mod x plus a will be a units left shift. Mod x minus a will be a units right shift, like it happened in quadratic, absolutely similar. Mod x plus a is outside, a units upward, and mod x minus a will be a units downward. I hope you can draw any graph of modulus, quadratic and linear. I hope this is clear to you. Similarly, let's say you have a circular. How do you draw a circular? X square plus y square is equal to a square. Here the center is 0, 0 and a is the radius. So taking center as 0, 0 and a as radius, if you draw a circle, it is something like this. So a, 0, 0, a minus a, 0 and 0, minus a. So that is how you represent a circular graph. Although circular graphs are not very frequent, but it is important for us to understand it. So x square plus y square is equal to a square. If you have something like x minus a whole square, y minus b whole square is equal to c square, in that case what does it mean? It means that the center is a, b and radius is c. Now let's take a question which is similar to a question that may come in CAT. So let's try and solve it. the kind of question that you get here is something like this. For x square plus y square is equal to 25. So it will be a circle, obviously. Center is 0, 0 and radius is equal to root over 25. So 5, 0, 0, 5. Minus 5, 0, 0, minus 5. So how many points lie on or within the boundary of the circle? Let's see. So x square plus y square less than equal to 25. I can represent this as an inequality also. So how many points lie on or within the boundary of the circle? So let's see how many points lie on. So first off, the points on the coordinate axis, we will count them in the end. Let's count the other points first. So if I take, let's find out the points, in this part of sector and then multiply it into 4 and then add the ones on the coordinate axis, right? So let's see here in this first quadrant, if I take x is equal to 1, then y can go on till what number? We have to take, so how many points lie on or within the boundary of the circle can be calculated only in case of integer points. Because obviously in case of non-integer there will be infinite number of points. To finitely calculate it, you will have to take integer. So let's say x is equal to 1, then y square is less than equal to 24. So y can go on till 4 square, because you have to get a perfect square to get an integer. So from 1, 0 it can go on till 1, 4. It cannot go to 1, 5 because then it will become 26. So 4 points here. When you take 2, 0 here in this line, you will have 2 square is equal to 4. So y square is less than equal to 21. So here also you will have 4 points, right? And again, if you take 3, 0, then y square is less than equal to 16. So here also you'll have 4 points. If you take 4 square is 16. So then y square is less than equal to 9. So then you will have 3 points here, right? And finally, so number of points here will be 4 plus 4 plus 4 plus 3, right? I hope this is clear to you. It's very, very simply. And finally, let's see if you take, so how many points here? 4 plus 4 is 8 plus 4 is 12 plus 3 is 15. So 15 in this part of the sector, 15 here, 15 here, 15 here, total is 60. Let's count the points on the coordinate axis now. So for example, let's say here, how many points do you have? Here you will have 1 point, 2 point, 3 point, 4 point and 5 point. Similarly, 5 points on each of the coordinate axis, so 20. And finally you count the origin also, which is also inside the circle. So how many points? 81 points. I hope this is clear to you. Again, a very beautiful application of graphs. Let's move forward. There can be miscellaneous graphs like y is equal to x cube or anything. How do you draw a graph when you don't know the nature of the graph? Simply by putting the points. For example, which is rare, miscellaneous graphs are rare, but if in case it comes, then also we should know how to do it. So x is equal to 1 if you take y is equal to 1. X is equal to 0 if you take y is equal to 0. So obviously passing through 0, 0. You take x is equal to 1, value is y is equal to 1. You take x is equal to 2, the value of y is equal to 8. So growing very steeply here, right? So growing very, very steeply, something like this. And if you have x is equal to, let's say, minus 1, y is minus 1. X is equal to minus 2, y is minus 8. So obviously in the third quadrant, because both x and y are, so you can draw something like this. So this is like y is equal to x cube. So in case of miscellaneous functions, what you can do is you can pick the points and draw the graph. But I hope the key ones are absolutely clear. With that, we come to the end of this. I hope you enjoyed. Keep working hard. All the best for CAT.